Now we are going to discuss about the compliance of lung. So what is compliance? There is usually a misconception between elasticity and compliance. So whenever I suppose, just in case if I have a rubber band and I try to stretch it, what is this? Most of us think this is elasticity. Absolutely not. This is not elasticity. This is the compliance. So when I leave it, it is going to recoil back. The rubber band is going to recoil back. That is called elasticity. So elasticity is the ability of the recoiling property of the lung. So coming to distensibility, so distensibility of the lung is the compliance of the lung, which is change in volume with respect to change in pressure. And we are going to measure the pressure in transpulmonary pressures. And coming to elasticity, it is the ability of an object to regain its original shape. So compliance is actually inversely proportional to elasticity. They are inverse of each other. So coming to the compliance of the lung compliance has been asked in MCQs also, which is 150 ml per centimeter of H2O. This 150 ml per centimeter of water is the compliance of the lung. Then coming to the chest wall's compliance is 200 ml per centimeter of water. Then combined lung and the chest wall, they have a compliance of 85 ml per centimeter of H2O. These are the different compliances we have to remember. Then coming to the compliance curve. What is compliance curve? Whenever we plot the pressure with a change in volume, that is the change in volume with respect to change in pressure, that is compliance. Whenever this was experimentally done for the lung, they acquired a curve something like this. In this curve, there is a portion which is the inflation. The inflation of the lung is happening like this, and there is a portion where there is deflation of the lung. That is the expiration during deflation. During inflation and deflation, when you compare both, it is not going through a straight line. So what is the reason behind it? And we can see, observe one more thing here. Whenever the same intrapleural pressure is, pulmonary pressure is there, the compliance during inflation is lesser. For example, take this point, this is the volume at this pressure, and compare the deflation curve. The volume is more for the same transpulmonary pressure, meaning that the deflation is having more compliance. The lung is having more compliance during deflation. So what is the reason behind this? And this is the reason why this hysteresis loop or the gap in between them is formed. So during inflation, what happens? The lung is trying to expand, and during that time, the surface tension, with what is the property of surface tension? It wants to collapse the alveoli. And what is the elastic nature of the lung? It wants to compress the alveoli. So both of these forces, we have to act against them. Now I have to inflate it against the surface tension and the elastic nature. While during deflation, deflation is the expulsion of gases or collapse of the alveoli that is happening. So while during deflation, both these forces are going to help. Both the surface tension as well as the elastic nature are going to help us. This surface tension is the most important factor among these two. So they experimentally wanted to prove that if we are able to remove the surface tension, the compliance of the lung should improve. So how can we remove the surface tension? Surface tension happens only whenever there is an air-water interface. If we abolish the interface, then there is not going to be any surface tension. So they tried to fill the lung with saline. They experimentally did it, and they tried to fill the lung with saline and compared with the normal lung. Obviously, saline-filled lung is completely useless, but still they wanted to study how far surface tension is affecting the compliance. And they found that whenever saline was filled, the curve was shifted to the left. Whenever the curve is shifting to the left, what does it mean? It means that for the same transpulmonary pressure, as you can see here, the compliance of the lung has improved. So basically, whenever you eliminate surface tension, the compliance is going to improve. So this is the experiment. So this diagram is important. And at the same time, the compliance curves were drawn for various disorders also, which is very, very important. So coming to this central one is nothing but a normal curve. We have drawn only the inflation and deflation one part. It is a normal curve. And some of the lung had increased compliance. Increased compliance means the distensibility is more and the person is having disease. This can happen in only one condition, that is our emphysema. Already I told you, in emphysema, there is loss of elastic tissue. Elastic tissue wants to collapse the alveoli. Now there is loss of elastic tissue, so the distensibility is increasing. And what is this disease? Whenever the compliance is down, any kind of restrictive disease. For example, we can take it as fibrosis of lung. So this is all about our compliance curves.